Hello, welcome to the another lecture of control system and instrumentation. I am Mr. Prajit Pal from Asansol Engineering College. Like to giving you some ideas about the block diagram reduction techniques and signal flow graph. Already from lecture 1 to lecture 3 respectively, I discussed several types of fundamental knowledges regarding control system, types of control system especially, that is open loop control, closed loop control, and what are the feedbacks, that those are the negative feedback system, positive feedback system, and what will be the effect of those, that is already analyzed. Besides, I have shown on those previous slides how to reduce block diagram with the help of block diagram reduction rules, and how can I use signal flow graph, and what is the difference between SFG, that is signal flow graph, and block diagram, that is also analyzed. Even I mentioned about the Mason's gain formula to be used to determine the transfer function or net gain from signal flow graph, and in continuation of that I will proceed further on this ensuing slide. Now, these are the relevant terms to be known to you people with respect to signal flow graph. Node, already I discussed, again I am repeating the fundamental ideas about those. Node, it is a point representing a variable. For the below diagram, see there are three nodes available, x1, x2 and x3. So if I am representing the compact SFG from this below diagram, then it will be, see, x2 is equal to t12 x1, because t12 is my transmittance parameter, or the gain, transmittance gain actually, because here my x1 is source, similarly x3 is also source, and x2 is my sink, that is inflow nature, all the arrows are entering on that node. That's why x2 should be treated as a sink node and represented as an output. So x2 is equal to t12 x1 plus t32 x3. Branch, a line joining two nodes. Obviously x1 and x2 are the two nodes. The line between x1 and x2 indicating with the help of arrow is known as a branch. Input node, node which has only outgoing branches, that is in this scenario x1 is in input node. Output node or sink node, only incoming branches will be available. Those nodes are known as output node. Mixed node, yes, has both incoming and outgoing branches. When we will solve relevant problems regarding SFG, we will see some nodes can be treated for some purposes. Either it can be incoming node, that means input node, or it can also to be treated as an output node, that is depending on the problem basis. Transmittance, it is the gain between two nodes. It is generally written on the branch near the arrow. See, according to this diagram where the blue color line is highlighted, there are four nodes are available, x1, x2, x3, x4, and the transmittance parameters are, see, that is these are the between x1 and x2 t12, between x2 and x3 t23, between x3 and x4 t34, and between x4 to x3, that is feedback, that is t43. So these things should be known to you people. Okay, then path, it is the traversal of connected branches in the direction of branch arrows such that no node is traversed more than once. Obviously, if I am looking the above diagram from x1 node to x4 node, obviously the path is nothing, that is path can be treated as t12 into t23 into t34, but you should not count t43, yes, that is already traversed, so that is the path gain. Okay, forward path, obviously I already spoke to you people regarding the forward path. Forward path on the above diagram is t12 into t23 into t34. So a path which originates from the input node and terminates at the output node, and along which no node is traversed more than once. Obviously in this scenario, according to the above diagram, x1 is my input node and x4 is my output node. Okay, so forward path gain, already I told you people just now, it is the product of branch transmittances of a forward path, that is t12 into t23 into t34. Loop, obviously that means initiation and termination point, if it is remaining same, then it is called as a loop. Path, that originates and terminates at the same node and along which no other node is traversed more than once. So in this scenario, the loop gain will be, if I am looking this one, the loop gain, see, x3 to x4, then it is coming back to x3. So the loop gain will be t34 into t43. Okay, so that is my loop gain. So in such a way you can proceed further to solve relevant problems regarding signal flow graph. Self loop path that originates and terminates at the same node. Obviously, loop gain, just now I told you, it is the product of branch transmittances of a loop. Non-touching loops, obviously there should not be any common node between the two loops. That's why it is known as the non-touching loops. And if we are considering this diagram, those things will very much prominent to you people. See, the compact SFG has been mentioned on the left hand side, and here my R of S is the actual input node and C of S is the actual output. So on that scenario, we will generate, how can I determine the loops and non-touching loops. Here see, the loops are, I am denoting L1 is equal to G2 H2. See, this is my L1 is equal to G2 H2, very prominent. Then L2 is my H3, yes, that is my self loop. L2 is my H3, L3 is G7 H7, L3 is G7 H7, this loop. And L3 loops, 3 permanent loops are available. Now we will see about any non-touching loops are available or not. Non-touching means if I am taking L1 and L2, that is G2 and H2 and H3, obviously those are non-touching, because between these two loops there has no common nodes. Even if I am taking G2 H2 and G7 H7, those are also non-touching loops, no common nodes available. Even I am taking H3 and G7 H7, those are also non-touching loops. So the possible non-touching loops are L1 and L2, L1 and L3, and L2 and L3. Okay, so in such a way you can proceed further to evaluate the respective gain from the given SFG with the help of Mason's gain formula. Now, rules for drawing SFG, that is signal flow graph. The signal always travels along the branch towards the direction of indicated arrow in the branch. The output signal of the branch is the product of transmittance and input signal of that branch. Obviously, it has been shown. Input signal at a node is summation of all the signals entering at that node. Signals propagate through all the branches leaving a node. Okay. Now, how to calculate the transfer function from the SFG? This process is known as the direct method or algebraic method. How to evaluate that thing? Here I will not apply Mason's gain formula directly. Here see 6 nodes are available, 6 nodes are available. Those are x1, x2, x3, x4, x5 and x6. So obviously my transfer function, my input is x1 and output is x6. So transfer function will be x6 by x1 is equal to what? That is my question. So in such a way we will proceed further starting from the input onwards. I will take 2 nodes at a time. One will be input and another will be output. When I am taking x1 and x2 at a time, x1 is my input node, x2 is my output node. So obviously taking concept from the previous or the basic thing of SFG, I can rewrite as x2, between x1 and x2, if I am writing the SFG equation, it will be x2 is equal to, if A is my gain parameter or transmittance, so x2 is equal to AX1 plus CX3. Obviously another inflow is coming from x3 node, that's why plus CX3. When I am taking x2 and x3, it will be x3 is equal to BX2 because no other inflow is coming to x3 node. When I am taking x3 and x4, there again I can rewrite as x4 is equal to dx3 plus fx5. When I am taking x5 and x6, it will be x6 is equal to gx5. Now I will eliminate all the intermediary nodes starting from x2 to x5 with the help of algebraic solution, algebraic elimination method. Then I can keep only the variables x1 and x6, and those elimination already you know, by which we can generate x6 by x1 is equal to see a b c d e g at the numerator divided by 1 minus of bc plus ef whole bracket plus bc ef. Now your job, you have to verify this result with the help of Mason's gain formula, because Mason's gain formula is already discussed. Whether this answer is correct or not. See, x1 is my input node, x6 is my output node. So my first job, I will determine how many forward paths available. Obviously straight cut only one forward path, that is, if I am denoting, that is p1, and its path gain is a into b into d into e into g. See, that is available, a b d e g. Okay, then it will be delta 1. Delta 1 I don't know, after that I will evaluate. Divided by 1 minus within the first bracket in sum of individual loops. How many individual loops available? 2 loops. One loop is BC, another loop is EF. So it will be C at the denominator, 1 minus of within first bracket BC plus EF, bracket close, plus non-touching loop pairs. Obviously these two loops are totally isolated with each other, then these two loops can be taken as a product for non-touching loop pairs also, plus C BC into EF. This is my delta value. Now delta 1 is due to the presence of first forward path. So delta 1 will evaluate it as like as delta, but it should not touch first forward path. So that will be 1 minus sum of individual loops plus non-touching loop pairs. In this scenario, when I am treating the first forward path starting from x1 to x6, it has touched all the nodes. So on that occasion, I can write delta 1 is equal to 1 minus 0. Other terms will be neglected. So it will be delta 1 is equal to 1. That's why see, x6 by x1 is equal to a b d e g by 1 minus of within first bracket bc plus ef, bracket close, plus bc into ef. Now I can speak my result is fully verified and it is okay, because it is verified by Mason's gain formula. Okay. Now, how to construct SFG, that is the reverse thing from simultaneous equations. Yes. Here see, the system of equations, algebraic equations are provided, that is y2 is equal to a1 to y1 plus a4 to y4. y3 is equal to a23 y2 plus a53 y5. y4 is equal to a34 y3. y4 is equal to a34 y3, and y5 is equal to a45 y4 plus a35 y3. y6 is equal to a56 y5. Okay, there will be 6 nodes obviously starting from y1 to y6, and we will see, and the respective path gains are provided, that is a12, a23, a34, a45, a56, a42, a53 and a35. Now if our first job, we will construct the individual SFG at first based on the individual equation, then after that, after obtaining all those, then we will combine all those SFG to generate a compact SFG. Okay. So see, when I am focusing y2 is equal to a12 y1 plus a42 y4, I will take 3 nodes at a time. Here see, that is, I will insert that thing. y2 is equal to a13 y1, sorry, this should be a12. So this is again is misprinting mistake. So it will be y2 is equal to a12 y1 plus a42 y4, because it is coming the reverse path from y4. When I am speaking y3 is equal to a23 y2 plus a53 y5, see, just I am constructing between y2, y3 and y5 only. y3 is equal to a23 y2 plus a53 y5. When I am speaking y4 is equal to a34 y3, just I am taking between y3 and y4, it generates y4 is equal to a34 y3. Now when I am speaking y5 is equal to a45 y4 plus a35 y3, see, between y3, y4 and y5, because y5 is my output, that's why direct path is y5 is equal to a45 y4. Then another bypassing path to avoid y4 node coming from y3 is, that is another forward path y3. So that's why it will be plus a35 y3. When I am taking y5, y6 at a time, it will be y6 is equal to a56 y5. Now I am combining all those, by which I can generate the compact SFG of those above. linear equations. This respective SFG is the compact nature. So I am drawing these reverse path in the below direction, some forward path in upward direction. You can draw this reverse path in the above direction, forward path even below direction. That is not a problem, but that concept, the actual drawing must be carrying the significant meaning, must carry significant meaning, then only you can proceed further. Okay, then only you can proceed further. Okay, so this thing is already analyzed. Now see, if we are looking this example, apply Mason's gain formula to calculate the transfer function of the given system represented by SFG. Here my R is the input node, C is the output node, and correspondingly the forward path to be determined before proceeding further, because this is the fundamental thing to proceed with the help of Mason's gain rule. So on that occasion we are saying two forward paths are available. If I am denoting P1 is G1, G2, G4, actually it will be G1, G4, G2, and rest gains are unity. And P2 is nothing, that is G1, G4, G3, because that is G2 and above one another path, that is gain G3, that is bypassing path. So two forward paths. So obviously Mason's gain rule already we know, that is the total transfer function is C of S by R of S is equal to P1 delta 1 plus P2 delta 2 by delta. That's why we have to evaluate what are the delta values. Now our next job, we will evaluate how many individual loops available. So L1, if I am speaking, the first loop is C, G1, G4, H1. Second loop is C, G1, G4, G2 minus H2, because that is the entire loop. And third loop is G1, G4, G3 minus H2. Okay, so these are the three individual loops. Now if I am speaking about the non-touching loop pair, C, L1 and L2, if I am taking, the common nodes are available. They are L1, L2 should not be non-touching loops. L2 and L3, that should not be taken as a non-touching loop. L1 and L3, that should not be taken as a non-touching loop. So obviously there will be no non-touching loops or non-touching loop pairs. Now my delta 1. Delta 1 means when I am evaluating delta 1, it should not touch fast forward path, corresponding fast forward path nodes also. When I am speaking fast forward path is G1, G2, G4. So obviously my delta 1 is 1 minus sum of individual loops plus non-touching. In this scenario there has no non-touching loop pair, so obviously some of the loops have been touched, the individual loops will be touched, so that portion vanishes. So delta 1 is equal to 1, and correspondingly for second forward path P2, that is G1, G4, G3, that on that occasion delta 2 also 1. So we can substitute all those values that generates here my 1 minus sum of the individual loops, that is delta, that is 1 minus G1, G4, H1 minus of G1, G2, G4, H2 minus of G1, G3, G4, H2 within the bracket. Then after that we can generate, because already I told you people delta 1 is 1, delta 2 is 1. Then after substitution all those, that is C by R is equal to P1 delta 1 plus P2 delta 2 by delta, it generates G1, G2, G4 plus G1, G2 G3 but divided by 1 minus G1, G4, H1 plus G1, G2, G4, H2 plus G1, G3, G4, H2. And you can take common on those and you can generate the answer. Okay, now again another SFG. Determine the transfer function C by R for the given SFG with the help of Mason's gain formula. Obviously in this occasion R is my input node, C is my output node, and we have to evaluate what is C by R. Successively we need to evaluate how many forward paths available. So according to this problem we will see there will be 6 forward paths and the respective gains are highlighted. So P1 is equal to C, G2, G4, G6, P2 is equal to G3, G5, G7, P3 is equal to G2, G1, G7, P4 is equal to G3, G8, G6, and P5 is equal to C, that is not direct forward path, some indirect way it will be a forward path, that is minus G2 G1 H2 G8 G6, and P6 will be minus G3 G8 H1 G1 G7. And individual loops are two loops are very prominent. P11 is minus H1 G4, P21 is minus H2 G5, and P31 is just like 8 numerical digit 8 type nature. See, that is G1 H2 G1 H2 into G2 G8 H1. So these are the three individual loops. Now we will see non-touching loop pairs. Obviously P11 and P21 are the non-touching loop pairs can be generated, because those two loops are totally isolated with each other. Now then we will evaluate delta 1 to delta 6 respectively, and individual delta value will be generated. So when I am speaking, so non-touching loop pair will be nothing, that is the gain product of this, that is P11 into P21, that is minus of H1 G4 into minus of H2 G5, that generates H1 G4 into H2 G5. So this is my non-touching loop pair. Now I will substitute the general delta value, that is 1 minus sum of individual loops plus non-touching loop pairs. That's why it will be 1 minus G1 H2 G8 H1 plus H2 G5 minus G1 H2 G8 H1 plus H1 H2 G4 G5. Okay. Now, so delta 1, when I have same nature of delta 1 means when I am evaluating delta 1 means I am focusing on first forward path, that is G2 G4 G2, see G2 G4 G6. Obviously the individual loop which is available on this forward path minus G4 H1 should not be encountered. So the isolated loop excluding this forward path, another loop is existing, that is minus G5 H2. That loop can be encountered about that. So on there are no non-touching loop pair. So when I am considering P1 is equal to G2 G4 G6, so loop will be L will be minus G5 H2. When I am considering P2 is G3 G5 G7, then my isolated loop will be minus G4 H1, and rest values of delta will be 1 because all the nodes have been touched. So see here delta 1 is nothing, that is 1 minus of minus H2 G5, just now I told you, that is 1 plus H2 G5, and delta 2 is equal to 1 minus of minus H1 G4, that is 1 plus H1 G4, and rest values as usual delta values evaluation you know, that is delta 3, delta 4, delta 5, delta 6 all will generate 1. Then you will substitute all those and generate the actual result for the given transfer function C by R for this problem. Okay. Now, how can I convert block diagram into SFG? Another very big important thing. So with the help of that, we can easily determine the overall transfer function of the control system by converting a block diagram of control system. Here see, the respective blocks are highlighted on the left hand side, G1 of S, G2 of S, H of S as the feedback element blocks, feedback transfer function, R of S and C of S is my input and output respectively, summing point is available. Now see, if I am mentioning on the right hand side equivalent SFG, see here my R of S is denoted by R, that is node, input node, and summing point, takeoff point is coincided with the node X1, and gain is G1 is highlighted with the help of the arrow, that just above the arrow G1. Direct gain G2 is highlighted just above the arrow, and reverse, that is feedback gain with its gain negative, is denoted by minus H, and that node, another node is denoted by X2 because on that occasion the takeoff point which is available at the outer portion and the summer, that should be coincided with the node that is denoted by X2. Then we can extend that thing up to the output node as C, and rest things are remaining same. Already you know how to evaluate C by R. You will apply how many forward paths available, 2 forward paths, P1 is G1 and P2 is G2. So L1 is obviously, L1 is only how many loops available, 2 loops available, L1 is minus G1H, another L2 is minus G2H, and there will be no non-touching loop pair. So delta 1, obviously all the nodes are touched, that's why delta 1 is 1 and delta 2 also 1, because due to the presence of 2 forward paths, 2 deltas will be available, and general delta is nothing, that is 1 minus individual loop, summation of individual loops, that is 1 minus of minus G1H plus or minus G2H, that is 1 plus G1H plus G2H. Then you substitute all those with the help of Mason's gain rule, that is T is equal to C by R, that generates G1 plus G2 divided by 1 plus G1H plus G2H. Okay. Now determine the transfer function, that is another thing, that is the block diagram reduction. Because see, SFG block diagram, all those things are very fundamental for control system. If this conception is very much clear to you people, then entire thing of the control system will be obviously clear. Determine the transfer function y of s by r of s for the given block diagram by using block diagram reduction rules. Already I discussed on previous slides. Again I am repeating for your convenience only. The respective block diagram is provided. So it is a little bit complex type of block diagram. So how can we proceed further for that? If I am looking this diagram, see, this diagram consists of G4 and G3. We can eliminate this parallel path. So these are two forward paths. Obviously we can rewrite as on the below diagram G3 plus G4. See that thing I made it, G3 plus G4. Then my next job, I will shift this takeoff point which is connected to H2, that is after this block G5, by which I need to add some block in accordance with H2, by which the actual result should not be disturbed. Then I may club with G3 plus G4 with G5. Otherwise it is not possible, because takeoff point is my obstacle. So on that occasion, what should I do? I need to shift this takeoff point after this block G5. Then in accordance with H2, I need to introduce 1 by G5 with that, and H2 and 1 by G5 will be cascaded. That's why see they are mentioned H2 by G5, and the respective takeoff point is available on the outside, that is. And then G3 plus G4 and G5 is G3 plus G4 and G5 is in series, that is in making in cascading nature, that is G5 into G3 plus G4. Then see, obviously we can eliminate the negative feedback path that is connected to H3, that generates G3 plus G4 whole into G5 divided by 1 plus H3 G5 into G3 plus G4. Then see, again we may cascade these two blocks at a time, that is G1 G2 by 1 plus G1 G2 H1 and G3 plus G4 whole into G5 by 1 plus G3 G4 whole into G5 H3. We may cascade it. Then we can eliminate this positive feedback path where the feedback function is provided H2 by G5. So where the feedback function is provided, that is H2 by G5. Now after cascading of that, that is generating G1 G2 G5 whole into G3 plus G4 divided by 1 plus G1 G2 H1 whole into 1 plus G3 plus G4 then G5 H3. Then we can eliminate this positive feedback path. And all of you know, I told the people, when the feedback is positive, the total transfer function, and if my forward path transfer function is G of S, reverse path means feedback path transfer function is H of S, and it is connected to positive feedback, then total transfer function will be G of S by 1 minus G of S H of S. If it is negative, then it will be, denominator will be 1 plus. So on that occasion, see, we can apply that formula by which we are generating G1 G2 G5 square whole into G3 plus G4 divided by 1 plus G1 G2 H1 whole into 1 plus G3 plus G4 then G5 G3 whole into G5, then minus sign is coming due to the presence of positive feedback, then G1 G2 G5 whole into G3 plus G4 whole into H2. Then that is my Y of S by R of S. All of you please verify the same, then only you can be able to understand, otherwise it is not. Please do lots of practice. These are the respective assignments. You please do it by yourself. Any problem you may ask. These are the very good assignments to you people, and already I told you people several times, these are the respective references. You can study from any kind of books, valid books these are. So that's all for today's lecture. Okay.